Today I'm going to talk about decimal busting when you have an equation. Say I'm given the equation 0.5x plus 0.57 equal to 0.3x minus 1.35. If I was to say that using correct mathematical verbiage, I would say 5/10 x plus 57 hundredths equals 3/10 x minus 1 and 35 hundredths. Looking at this, I want to combine like terms, but I have to be strong on my decimals, and maybe I'm not comfortable with that. So I look at each of the different terms to determine the term that has the most number behind the decimal, the most amount of numbers behind the decimal. There's one number behind the decimal here, two numbers behind the decimal here, one number behind the decimal here, and two numbers behind the decimal here. So I need to adjust for two numbers behind the decimal. Because our decimals are base 10, we're going to be using factors of 10 to do this. I want to move the decimal twice to the right, which I can do by multiplying each of the terms by 100. When I multiply 1/100th times 100, I get back to 1. Using decimal multiplication, 1 times 100 is 100. 0 times anything, I've got 0. But I have two numbers that need to be behind the decimal, which lands me right here, which is why I have 1. The shortcut to this is, if I'm going to move my numbers twice to the right by multiplying by 100, I just have to make sure that I do it to each thing. So I'm going to take 100 times 0.5x, or 5/10 x, plus 100 times 57 hundredths equals 3/10, I want to multiply it by 100 times 3/10 x minus 100 times 1.35, or 1 and 35 hundredths. This is going to cause my decimals on each of these terms to move twice to the right. I've got 550. This is 50x plus 57 equals 30x minus 135. And now I'm in terms of just integer values. I want to combine my x's. I'm going to subtract 30x from both sides of the equal sign. And I have 20x plus 57 equals negative 135. I subtract 57 from both sides, and I get 20x equals negative 192. I divide both sides by 20, and I get x equals, I'm going to reduce this by 2, and then I'm going to reduce it by 10. Negative 9 6/10. If I want to check my solution, I have to plug in my negative 9.6 into my equation. I have 0.5 times negative 9.6 plus 0.57 is equal to 0.3 times negative 9.6 minus 1.35. 0.5 times negative 9.6 is negative 4.8 plus 0.57. 0.3 times negative 9.6 is negative 2.88 minus 1.35. 0.57 and negative 4.8, these are opposite signs, so I'm going to actually subtract and do 4.8 minus 0.57, and I get negative 4.23. 2.88 and 1.35 have the same sign, so I add them and keep the sign, and I get negative 4.23, or negative 4 and 23 hundredths. So when you're solving an equation using decimal busting, you're essentially looking for how many numbers are behind the decimal, let's say I have 0.123. There's 3 numbers behind the decimal, so I'm going to need to move it once, twice, 3 times. That means I'm essentially multiplying by 1,000. I have to be consistent, and I have to do it to every term that's in the equation to make sure that I am not changing the equation and keeping it equal. I hope this helps. Thanks for watching.